is a really exciting place to be.
Yeah, that's awesome.
And then it's your job to actually go get it done.
If you feel it's meaningful, there's a good chance other people will feel it's meaningful as well.
Okay, hi, welcome everyone. We are here for to talk about you and what you're doing. So can you first introduce yourself, tell us who you are and what you're doing?
Hi, Jeremy. Thanks for having me today. So I'm Aaron Brown. I was a content developer with Udacity, and I'm currently working with Mercedes-Benz as a senior software engineer on autonomous functionality. It's been an interesting journey in the realm of self-driving cars.
So I actually met you or knew about you first when I learned about self-driving cars through Udacity. Can you maybe tell us how that happened for you? Like, where did you study, graduate, and how did you end up working for Udacity?
For sure, yeah, it's an interesting story. So I studied electrical engineering back in school. Back in college, I was interested in AI, but I didn't have the time to take some of the classes there. I was just trying to graduate. I was working in the semiconductor field for some time, and I was learning about AI in my spare time just from YouTube, and I found out about Udacity. I got really excited about their machine learning nano degree, to a point where actually I decided to study it full time. And then also the self-driving car degree came out shortly after I finished the machine learning degree. And they were actually holding this meetup at the Computer History Museum in Mountain View. And I decided to fly out to it. I was really excited to meet the faculty with Udacity and the other students. And it was really exciting. Since I was working on the nano degree full time, I was talking to David Silver actually, and he said, "Why don't you come and help us out?" And so I started working with Udacity at that point. At first, I was remote, just doing content development, but I decided to take the adventure and move from Boise, Idaho, to Silicon Valley and be really close to the project. Yeah.
So you actually went to, like, did you rent an apartment or something like that?
Yeah, it was kind of a shock because I went from living in my own house in Boise, where the mortgage was like not so terrible, but to going to like Silicon Valley, having 3 roommates and like paying like over $1,500 a month. It was kind of a shock, but it was totally worth it because it was just so cool being in that kind of atmosphere, that kind of vibe. I got a lot out of it. And then with Udacity, it's interesting how it evolved. I was passionate in games, actually. In my spare time, I was working on creating my own game engines. I was familiar with Unity, and I actually got to use some of that experience with Udacity, building out some of the simulation projects, all of them using Unity. That was really cool to do.
Okay, yeah, I kind of remember some projects around that. So how much time did you work? How long did you work at Udacity, and maybe more like, what did you do exactly?
Yeah. So I think I was with Udacity. So it started off in 2017. I think that went up to the end of 2018 or so. Yeah. And so it's content development for self-driving car. I remember I was going through a lot of the videos and kind of helping to explain how to go through the projects. One of the first tasks too that I had at Udacity was working on the behavioral cloning and kind of just sharpening it up in the simulator. And from that, actually built out one of the projects for the planning course, which was a really fun one to do because it was a virtual highway.
Yeah,
I heard it was
quite
difficult, but I remember even seeing some people on YouTube who had a lot of fun with it, and because you had a lot of freedom in that project. I thought that was really cool. and you also had a lot of freedom creating the solution too. But by the end of it, you could actually create your own planner that was doing lane changes and going at the velocity, not breaking any of the rules, not breaking any of the kinematics, making sure the ride was as comfortable as possible. Yeah, it was just it was a blast to do, and also seeing the reactions from students that worked on it. I also got really into Slam as well, as building out some projects there. One of the most memorable moments is like when Sebastian actually sat down with me and helped me build out a Slam and pointed out this bug that I had in the range, and that was so cool. Kind of having like the creator of Slam with me while creating that out. And I got really into LiDAR data and just creating these dense maps using LiDAR. So algorithms like ICP and NDT, which we were using to actually create a map that then students were localizing to in the final project. I thought that seemed like magic, and I just loved learning about those later on, and even created some courses about that in the revamp self-driving car program. But before that, it was doing the obstacle detection with LiDAR. So if you have a point cloud, how do you actually filter that out, see the ground plane from your objects, and then doing Euclidean clustering to identify those objects. And that was really cool, just kind of sitting down with C++ and making that as efficient as possible.
Yeah, I remember like taking that course during COVID, and that was like there was a lockdown, and Udacity had an offer where I think you had a 3 months or a month that was discounted or something like that, and everybody took advantage of it at some point. And I worked on sensor fusion, and I remember you were working with someone else who was doing the camera aspect, and you were more on the LiDAR, and that was really cool. So how has it been working with Sebastian Thrun?
He's a great guy. I love how curious he is. And I love his teaching style, like how he's able to break down complex subjects. I really love his AI for robotics course, and how he really simplified concepts like common filters, PID controllers, and even SLAM as well, to like a very basic foundational point that you could grasp it, and then to a point that you could grasp it and actually grow from there and do more with it. So yeah, his teaching style and the way he's able to explain things is really remarkable.
Right. So I remember when you were working on the self-driving car aspect, there was the Mercedes-Benz team also teaching. And is this how you ended up joining them?
Yeah, it's an interesting story. So back when I was talking about going to the Computer History Museum, so Mercedes-Benz was there. I really wanted to talk to Mercedes then, but it's quite tough because they were just everyone wanted to talk to them. So it's interesting that
You mean everyone at Udacity?
Yeah. So
Okay.
Axel was there, but he was just basically very popular, I would say. Like everyone wanted to have the chance to speak with him. And it was interesting how I actually ended up working with Udacity, and that was actually the bridge that helped me work with Mercedes-Benz, and also kind of gain the experience with the self-driving tech to work there. With Mercedes, ever since I was a kid, I always really admired their cars. And yeah, they're really nice cars, just really well made. And it's also quite exciting how they were kind of a pioneer in the self-driving space. Ever since they had some of the earliest like lane keeping back in the market since like even like 2011, and even like in the late 80s, they were doing distance keeping. So it's pretty cool how they've been like a pioneer in that space.
And so, do you feel like they are? How do you feel about them in the autonomous space today? do, I assume you work on the autonomous side. So can you tell us a bit what you're doing and how you feel about that part?
Yeah, I don't know how much I can say. I think it's quite
Sure.
confidential for some aspects, but yeah, I mean, I get really excited about the vision of self-driving cars. I think like a lot of people kind of forget that not everybody can drive, and especially like living in the U.S., if you can't drive, uh, it's really hard to get around, and it even like you can't work at certain
Impossible. Yeah.
jobs because of it. Yeah. So like the vision of having a self-driving car actually I feel like gives more freedom to people and also enables people who can't drive.
I actually
Um,
really like the voyage idea with retirement communities and all of that.
yeah, yeah, for sure. I love Voyage and um, then what was going on, like the vision now that Waymo's had in Cruise. Um, I've used Waymo cars in San Francisco, and it's just like amazing seeing it in action. I'm actually really excited that it's expanding to the rest of the peninsula in the Bay Area as well, and then Los Angeles. Yeah, I think it's a really exciting technology.
So what are you doing at Mercedes? Can you, on the extent of what you can share, could you say maybe what team you're on and um, what is maybe the main project you're on right now?
Yeah, so for sensor fusion, it's taking in um, multiple sensor data, these like camera, ultrasonics, radar, and then being able to have a perception of your environment. And then having this accurate perception can then be fed to a planner. This is with the parking functionality. So imagine you're in a parking lot and you want to have advanced parking autonomous features that will help you park your car. It's funny, like sometimes parking can be harder than it is, especially if you jump into a car that you've never driven before. So just having something that enables you to be this expert parker would be really useful. And also, this vision that you go to a crowded parking lot like Costco, and it's kind of stressful. You're kind of driving around searching for a parking lot. There's all these people. How nice would it be if you could actually just have the car go park itself and
Yeah,
you can just get
definitely.
out and save time. So it's all about time savings. And then even things like being in a car and you're trying to parallel park, and then one of the worst things that can happen, especially if you have a nice car, is if you have like rim rash and you go against the curb and like, oh no, what if you could have this system that takes that fear and stress away, this potentiality of actually having that happen, or being in a parking lot and like hitting, like the worst thing you can do is like hit another car or hit any objects. Like just having this advanced parking functionality that takes that stress away, like that even potential possibility of that damage happening, is so valuable, so useful.
And so this parking functionality, so you're working on it, and could you tell us maybe what are some main algorithms on that? Um, is this more like um, classical approach or deep learning or
So
anything
what I
else?
work on is more the deep learning. So
Okay,
using neural networks to take in the inputs and then infer your parking scene.
okay,
Oh.
okay, great, cool.
Hmm.
And so I told you just before I've actually been to visit Mercedes-Benz India, um, and I really love the I don't know, the building, like the people going there and working on research in autonomous driving, etc. Can you share like how Mercedes works with um, India or Germany or maybe other places in the world?
Yeah, it's a global company. Um,
I mean, on the autonomous driving side.
yeah, so I've had the chance to go over to Germany a couple of times. One of the best experiences was going to Immendingen. They have a huge test track there. That that was really cool to see. And
Okay.
driving around in Germany as well. It's quite different than the U.S. Well, the roads are quite spectacular there. I actually did a couple of cross country drives. It's amazing, like just driving to another country, and it only takes like 4 hours or so. It's like, oh, I'm in Germany now. I'm over in Czech Republic, and then even to Austria. Yeah, those are some
Have you
nice
been to
experiences.
Have you been to Europe? Do you visit? I'm from France, for example, from Paris.
Hmm. Yeah, actually, I have been to Europe. Um, yeah, a couple times now. I've been to like the south part of France. Um, been to Italy, um, and Spain. Yeah, really
What do you
enjoyed it
feel
over
about? I would say self-driving cars in the US versus Europe.
there.
Do you feel like it's going to be much easier in the US?
Hmm. Well, I get really excited about some of these current architectures that are happening right now, kind of these foundation world models, because I think that's a really scalable approach where it doesn't really matter where you're at in the US or Europe, but you can learn those kind of driving behaviors. So I was actually in Amsterdam and I was in a car and I was pretty amazed by the driver because it was probably one of the most complex driving scenes I've ever seen because he's weaving in and out of pedestrians going all over the place. And it's such a balance because you can't slow down or it's all of a sudden the pedestrians are just going to go and you get stuck. But you can't obviously hit a person at the same time. So you have to be somewhat aggressive. And this is complete dance. And I thought, like, if a self-driving car could do this, then that's amazing. Um, so that was in Amsterdam. And so, it really had me think it's like you really want this kind of architecture that could thrive even in these most complex scenarios. Another, interesting use case is so we're talking about self-driving cars. Like the ultimate goal of a self-driving car is to get to a level 5. This is a car that can drive anywhere in the world at any time of day and drive just like a person. So they could drive just like a person in Amsterdam. And this includes actually severe weather. So
Yeah.
being over in California, like to go skiing and you go up to Tahoe. I was just in Tahoe recently and we were driving through a blizzard. You can hardly see anything. It's pretty white. It's like white out. And yeah, just very complex driving conditions, but still as a person, I'm able to do this, but a self-driving car, like that's quite a challenge. But it's a challenge because it requires the right architecture. And you really want an architecture that's kind of like mimicking what biology is doing. So we could even talk more about that. I read some interesting books in the past
I
that
think
kind
that's a
of,
great transition. You mentioned so world models. Maybe you can continue there.
yeah.
Biology.
I mean, so I really got into AI and then being at Udacity and focusing like on self-driving cars. So self-driving cars is a great problem for AI. Um, but I at the time, like back in like 2018 or even up to 2020, like I was almost a little disappointed with AI. Like I felt like it was pretty brittle, especially for like reinforcement learning. The perception was there, but there's all these things like adversarial attacks, like a CNN. You add just a little bit of
Mhm.
noise, and all of a sudden it can't see the object. So it was, yeah, it's kind of this fleeting feeling. At the time, I really wanted to understand AI deeper, and the one of the nicest inspirations you can have is like biology, like and how it's doing it. I found this one book. It's by Jeff Hawkins. It's called The Thousand Brain Theory, and he's just over in Redwood City. Their goal is to actually like reverse engineer the human brain. Um, and from a high level, they actually had this really interesting idea, and that it was basically about the brain is just trying to maximize expectation and minimize surprise. And so you're always actually trying to anticipate what's going to happen next. And if it is what you expect, then everything is as it is. But if something different happens, you actually learn from that and you update the model. And this is kind of like this world model idea. So we all use this world model. And I thought it was really interesting because I never actually had thought about it like that before. And it was just really interesting because like things like ChatGPT, like later it came out, and it's actually just that's exactly how it works. It's trying to maximize expectation, minimize surprise. Basically, see some data, input data, and it's just trying to predict what the next data is going to be. And through that mechanism alone, it's able to learn the underlying structure and whatever space it is. And that's kind of the beauty of it. It can be any space, it can be words, but it can be multi-modality as well. It can be images, it can be audio, kind of with the brain as well, because in the end, everything, like if it's vision, touch, or hearing, it all ends up as electrical signals in the brain anyway. So that's just like really interesting how that kind of works.
So yeah, I see what you mean. A bit like the input of a transformer. Like it doesn't really matter what that is because ultimately it gets processed, it gets tokenized, and then we can work with that. So maybe can you tell us about world models? What is a world model exactly, and why suddenly people are moving from training on the Kitty dataset to training on the entire internet? Like how did we end up here?
Yeah. So I think like the mechanism that Transformers has specifically with the self-attention is actually really powerful. It's able to extrapolate. Like one example is you can train it on adding up numbers, and then you can show it numbers that's never seen before during training, and it can still get the right answer. This can actually be extended to other problems as well, which makes it really sample efficient, where it seemed like other previous architectures were doing a lot of kind of like just overfitting, and they could generalize to some sense, but just not as well as transformers with this self-attention. With transformers, so this mechanism is great, but it's also scales quadratically with its complexity. So that means there's this limit to how your context window can look, and it can get quite expensive. It gets bigger. What's exciting that's happening right now is these new architectures like Mamba, and Mamba can scale nearly linear. And that's actually going through and creating these custom CUDA kernels that allow that. And then you can even do things where you actually add in self-attention with Mamba. So you have these really hybrid structures. So now you're seeing these kind of world models like Gemini 1.5, which is like 5 million tokens. You know, they can feed in an hour-long video, and then you can actually query it. Imagine watching like a recorded lecture, and be like, when was the professor talking about this one subject? So it can query the whole video and be like, oh yeah, it was right here.
That
just
is,
so
I
that kind
think
of
that is
context.
really near this idea of having that. I think maybe integrated on YouTube or some. That is near, right?
Yep. And then with that kind of context window, you can even like query like an entire code repository as well. So it has that entire context in it. And then also just for like, going back to like self-driving cars, like you can have that for your input space. So no matter what you're working with, like this camera data, this LiDAR data, this radar ultrasonics, these are huge, dense information packets of intensities. But if you have this huge context window, you can look at the whole information and try to see what's going on. With like transformers and this tokenization. So basically, because you're limited by this context window, what was happening with ChatGPT. So every word is like its own token. And then what was happening in the image space is like this vector quantization. So breaking down an image that's very high dimensionality and using vector quantization to kind of make it more obtainable in this sort of tokenized form. But with these new architectures too, you can actually get more resolution from it. So you could even have these large language models that are looking at it from the bit sense. So right now it's kind of biased where you have a word as a token, but imagine if it was actually like looking at it through like the bit resolution, and then you have like less bias from it as well. So yeah, basically these architectures are really what's driving the performance of it. Even things like diffusion. So it's like, the magic recipes, the transformers and diffusion. So diffusion is also using transformers. And then there's like stable diffusion 3, and they did something really interesting where they replaced the UNet architecture. So UNet is something kind of famous back in like 2016. Like back then, the real excitement was with the CNNs. That was what was kind of like driving the excitement for like self-driving cars, and it was making a huge impact for AI, semantic segmentation, and all these new features. So now you have that again with, okay, so Stable Diffusion 3 actually just did entire transformer architecture there. And then it's actually able to do things like spell words correctly, where kind of like image generators always struggled with spelling, and now they can actually succeed with that.
Okay, so do you think, would you say that this is somehow the answer to, because we've seen autonomous driving going like crazy in 2017, there was like some golden era.
I think because of CNNs, and that was like huge. Like I remember when I first saw semantic segmentation, I thought that was magic. It's like, wow, oh, this is incredible, you know?
But then we went to a place where people started to, because it started to work, so people started to add regulations. Because I think, like personally, if it did not really work, we wouldn't have all these regulations and people going after them. And now we are in a place where it's been more complex for self-driving cars, and people realize it's going to take a bit longer than 2020 or 2023, or now it's going to be a bit longer. So do you think that the idea of world models can be a viable solution to maybe get there faster? Like, do you think we could have just exponentially in terms of pace, like ChatGPT driving a car? Because the pace at which everything changed was like last year we did not have any of this, and suddenly we're in a world dominated by AI. And could we have like this enabling this speed for autonomous driving?
Yeah, so the thing back in like 2016 with like CNNs and everything, so this was all supervised learning, right? And
Yes.
The thing with supervised learning is these labels have to come from somewhere, and usually they're coming from a human, like an expert system. And this takes time and money to actually create these labels. They don't just come from a black box, or you can't just generate them as easily as your input data itself. So that's a bottleneck. And with these new architectures, like the biggest transformation is actually that it's self-supervised. And so that means you're just using the input data alone to learn the structure. And that scales terrifically better than a supervised system where you have to kind of, create these labels. You don't have them at hand, but a human kind of has to look at them, and you have this hybrid structure. So that scales way better. So that makes a big difference.
What I've seen from self-supervised learning is that we want a label, but we don't have it. So we are going to create some kind of fake task to, for example, contrastive learning, and we're going to try and still learn from something and then use that learning to then solve the task. Do you think that it's just some kind of trick, or can it be really like that powerful?
Contrastive learning is interesting, and I know like Jeffrey Hinton actually just came out with something recent for contrastive learning, but then you have to have like negative samples, and that gets actually kind of expensive as well, right? So if you're just doing MNIST or something and you had like a number, then you have to have like the opposite of a number. And there's actually like an infinite number of possibilities for like the opposite of this number if you're just thinking of like the manifold of numbers. So then that actually takes time and energy to do. What's actually better is if you can just use positive examples. So like Jan LeCun is a big supporter of this in energy models. It's pretty interesting. And so with this kind of energy model, then you're only trying to learn from positive examples. A great example of this is actually like a variational autoencoder, where you can actually use it to just see positive examples, and it can actually tell you the energy if it sees something else that's like far away from it or not. And this is really scalable. This is really nice, because then you can just learn the difference of something just from seeing the images itself. It's like if you only saw images of cats, for instance, then you could see an image of a dog, and without ever seeing a dog before, you can say, oh, well, this is way different than what I've ever seen. I think that's a pretty important mechanism. there's this kind of interesting philosophy going on right now with like generative mechanisms and more like models like energy models. This non-generative, where the loss function isn't exactly going back up to the pixel space, but it's just trying to do more like a bootstrap your own latent and see the differences in the latent space itself. But the idea is that you have this idea of uncertainty. So if you see something, you have a distance metric of how similar it is to something that you've seen before or not.
Yes, the idea is to use that. So that's still contrastive in a way, because you're still doing some kind of difference to learn.
Mm-hmm. Yeah, that kind of goes to where there's, this saying of self-supervised learning and unsupervised learning. I kind of like what Jan LeCun said, where it's like the term unsupervised actually doesn't make quite amount of sense, because there's always some supervision, right? There's always some contrast. Mm-hmm. So when you're talking about something like ChatGPT, or just any mechanism that's trying to predict the future based off the past, the supervision is what it's actually seeing right there. Like it's actually able to take this action. It's like I make a prediction, I see what actually happens, I look at the difference. That's the supervision that's happening right there. And that tells you whether you're doing well or not. There's always like some contrast. And that's how we understand the world anyway, just contrasting between states. Like reality is like time and space. If you're living in a universe where there's only a single snapshot, one state, that'd be almost meaningless. Like one state by itself is meaningless. And the only way it makes sense is by contrasting it with another state, in this case through time. And that actually gives structure, that gives meaning.
Okay, so to continue on AI, like where do you think this is going to go in terms of, so autonomous driving, like, so I would have maybe two questions, which would be on the autonomous driving side, do you think we're going to really implement these ideas? Like, is Mercedes-Benz or other companies going to take ChatGPT and world models and put them into self-driving cars? And in the AI side, where do you think that this entire thing is going? Like, do you see this idea of us engineers continuing to learn about this at some point? Or is this going to become like too complex either to learn about or to simply work on it, because we won't have all the data and all the processing power? Because we can always like purchase an NVIDIA GPU and train a model on that. But if you have to have entire rooms and an entire like giant internet and you train for weeks, then it's no longer something that engineers can do. It's more like a few companies in the world and that's it. So where do you think this is going?
Yeah, so from the engineering standpoint, you want the most scalable solution. And I think in the past, more is even more brute force. So it's actually becoming less and less brute force. So when you're using these previous deep learning architectures that were doing supervised, I think you actually required a lot more data. And actually with this trend of these more abstract architectures like transformers, they're actually more sample efficient. And I've seen this in some experiments, just talking before about like adding numbers, for instance. And I think we'll actually get to a point where we'll have architectures that need a lot less data. So imagine right now with these world models, like companies like Wayve and Tesla. So they're using it right now. And then it's seeing just a massive amount of videos in order to be able to have the car drive using this world model. But I think the architecture will still evolve, and it'll evolve to the point where you could actually maybe just take the car over a summer and drive in specific places, and more like a human's journey. Because right now, like the car is seeing a much more massive amount of data than any human has seen. I mean, same with ChatGPT and things, and that's where it gets this impressive capabilities. But it can scale to the point where it's more like I'll take the car and I can drive it around just like any person would over like a year, and then it's able to drive really well. And then you won't need as much data. It'll become more sample efficient because we kind of know that's possible just from like the biological use case. But yeah, from the engineering standpoint, it definitely makes sense to go with the solution that's more scalable. And the reason we're using more brute force methods in the past with like deep learning is because we didn't know any better. I mean, that was the solution that we had, and you work with the tools that you have in your toolbox. But then over time, you discover new tools, and you can do more with it. So I think like the more less scalable solutions with like the pure like supervised learning and even like classical robotics, those could have worked if we had an easier infrastructure to begin with. It's the reason we need such sophisticated architectures because the infrastructure is massively complex. And also, one of the things is you're driving with other humans on the road, and humans like to, be interesting when they drive. Everybody's got like their own thing when they drive. Some people like to take it nice and easy. Some people are like racing around and changing lanes suddenly. Some people are just like
Actually,
tailgating.
I was seeing a video the other day of Tesla and Elon Musk driving with end-to-end learning, and basically he was saying that it's learning from the data set, but nobody really stops at stop signs. It's like they don't
Yeah.
really stop for 3 seconds like they should.
Right, because
They
it
just
doesn't entirely make
pause and
sense.
then
If there's
continue.
nobody around, you're just kind of like, okay, well, there's nobody around. There's low risk of anything happening, so it's kind of natural. And also, it's an interesting balance because it's game theory. Basically, when you're driving, it's game theory. You're trying to optimize your own goals, but at the same time, you should be optimizing other people's goals too. And if you're doing
Mhm.
that well, then everybody's happy. And if everybody's happy, it's a very smooth way of driving. So in a stop sign too, like you're trying to do it, but if you're thinking about game theory, like I want to stop, but I also want to respect everybody's time. So I'm going to stop, in the minimal amount of sense that everyone understands I'm stopping and just keep going with the flow to maximize everybody's kind of expectation and preference. And then when you violate somebody's preference on the road, then they get like mad at you. And so you really do want like a car that can like mimic a human because you want everybody all around the road to be happy with you. You want to be like predictable, and you want to like make sure that everyone's in a good flow. Yeah.
Yeah, one thing I particularly liked was so you mentioned Wayve, and I'm not sure if it was Wayve or another company who shared like you have the video and basically you're chatting with a
Yeah.
model that tells you what's going on. Like I'm paying
Mhm.
attention on the red light, and then I'm
Yes.
going to pay attention on the road. And
Yep.
so
That's actually quite
when you're
incredible.
looking at
And
this, you're thinking it could basically drive, right?
yeah, and also bridges the understanding of what the car is doing. So there's this big fear. You talk to people. I remember even back when I was working at Udacity, I was very excited to work on self-driving cars, and I would tell people I'm working on self-driving cars, and they're like, "That's terrifying." It's like, well, it's not terrifying, but it's like, but then you think, why is it terrifying? It's because you can't really understand this system. You feel like it's a black box, and that's actually natural. So you fear anything that's like unknown or unpredictable. So it's like, oh, okay, so that's why it's scary. So how do you fix that? Well, you actually make it more of a white box. You open it up, make it transparent, and language is a great way of bridging communication. I mean, we all use language to communicate, so it's actually very natural for the car to communicate. And also, if you want this self-driving car, if you want it to be practical, you want a really natural UI interface, and so language is a great way of doing that. So imagine being in this car and you want to like change destinations or anything, or just tell it to change its driving style in any way. It makes a lot of sense to just be able to tell the car that, like a chauffeur. So then it's actually like having your own robotic chauffeur. That's really powerful too. Like when something happens, and you're like, you don't understand why the car is acting a certain way. You just ask it, why are you doing this? And the car's like, oh, this and this. And like, then you can actually tell it, and you can even teach it like, well, I don't want you to do this. Can you just do this instead? And the card's like, oh, okay, yeah, I could do that. Try. And so
Mhm. That's
that's a
amazing.
really streamlined, and you can learn actually. You can learn from your preferences. But like, I like this kind of driving style, and like it
Yeah,
can remember that and be like, I'll drive like that now. And you can have your own profiles for the driving behavior.
exactly.
It
Yeah.
makes a lot of sense. I think it's pretty cool what Wayve has done with world models, and they've been like really into it. I think like even since like 2018, even like before we have the advanced architectures that we have now. Um, One of the earliest world models I saw was one from DeepMind. It was like the recurrent state space model. And that was with reinforcement learning in video games. So one of the things that got me into AI was reinforcement learning, but it was always a pain to train because you'd just be sitting there, okay, I'm going to launch it up and you just watch it go. And then it's really boring and you're just kind of waiting for it. And then you try running it and then it's like really bad. And then you're like, why is it really bad? Kind of like going back to like, if you just had like language and you could ask it why it's doing things. But with this kind of world model, it's more like it actually gets to the point where it can learn to be the game. And that's actually kind of exciting because then you actually, it understands it because it can actually generate it and it can be it. So that's what DeepMind was doing with this RSSM. And it was just kind of amazing because you could actually get a neural network to be a video game. And that got Wayve really excited. Wayve was doing stuff with that, even in Carla Simulator. And now the architecture is not with this RSSM. It was doing well, but it doesn't perform as well as you can with these more architectures like transformers and diffusion with this kind of like decoupling dependency mechanisms of attention.
So can we talk more about learning world models? Because now I really want to learn about world models, and I know that you're building a course on that. So can you give us some kind of teaser of how do you learn about world model and what is the objective for an engineer going out of a world model course?
Yeah, so kind of wrapping up this course with Udacity right now, it's a discovery course. It just talks about world models and it's everything kind of from this high level view. But I think like one of the best ways of learning about world models, I always loved that Sebastian would say this as well. So there's one thing just like watching a video and watching someone teach something. It's almost like working out. It's almost like exercising. It's not until you actually do it yourself and try it that you actually build up the muscles and the ability to really understand it and do it. I think it's the same with anything, and also with world models too. What's nice about it is it works with like any modality because it's just a very general thing. The inputs could be just any sort of like vectors of intensities, and it learns to predict this new vector of intensities. So you can do it inside a simulator, for instance. Like you could even have like a self-driving car simulator like Carla, and you could use a world model on that, and then you could actually learn, the world model would learn to be Carla, for instance, and then you could like drive around inside the world model. And then the world model is just the first step. And that's useful for other things like planning and reinforcement learning. So it's like just this very good predictor, forecaster. And it's not biased in any way. It's just trying to generate something that meets the minimal amount of surprise. Like that would be the most reasonable thing to see from it. And these kind of world models, so you have a passive observer like ChatGPT, which is seeing text and text. But where it gets interesting is when you combine actions with this. So you can think of just like, okay, let's think about a video game like maybe even just Carla, and you have a camera image. We could even think about one of the old Udacity courses with like behavioral cloning, where you have a camera image of your track, and then you drive the car, so it gets input about like the throttle, the amount of throttle pressure you're putting on it, and the steering angle. And you see sequences of these. So state, action, state, action, state, action. You feed this into a world model, and then what it's going to predict is the next state. And this is autoregressive. So you can say, well, I've seen these states, and I want to put in this action. And you'll get a new state. And so you can take that new state and put it back and say, now I want to do this action. So it's autoregressive. And then all of a sudden, it's a simulation simulator. So the neural network learns to be the simulator, which is really cool. So then you could use that. It has this really good understanding of latent space of the dynamics of the world. You can do planning with that. So then you can do like behavioral cloning. So behavioral cloning never really worked too great in the past. So we looked at it with Udacity, and back then it was just like CNNs. Yeah, it was just a CNN that was taking your state, breaking it down, and then it was outputting an action. So the action was supervised or driving it around. And you could take it from one track and then put it on another track, but then it was really hard for it to be generalizing. like the any track. That was because of the architecture itself. But with these new architectures, they actually do a much better job at generalizing. So then you're actually seeing this work now with robotics. So there's like companies like Mobile Aloha was an interesting example over at Stanford with DeepMind, where they teach the robot through teleops to do tasks, and then it can do this task in autonomous mode, and you can even get it to be slightly different vision of the task. Like it's pushing in chairs, it's never seen this chair in this exact combination before, but it's still able to do it because of these kind of like attention mechanisms. It can abstract better. Figure AI is able to watch videos of people making coffee, and then it's able to make the coffee and do self-correction. So it's not as brittle as it was in the past, where it can actually get into a state that it's never seen before, but still recover from that state. And I mean, this is also what's going on with FSD12, where it's just learning from videos of people driving. It's saying, okay, well, in this video, this person is driving, doing these actions. So it'll be in some new state, and it'll be different than any of the recordings it's seen, but it's able to kind of see the closest example and then say, okay, this is the action I should do. And then this is entirely through the input data space, right? This is not labels or anything. So it's spectacularly scalable. So it's all through input data domain. You can create these systems then for planning and doing this kind of reinforcement learning. But yeah, you could do this in virtual space. You could do it with video games. And if you get good at it in the video game, what's nice is the architecture is general enough that you can actually do it in real life. Looking back at simulators for self-driving cars, like the one argument was that it's really hard to make the simulator realistic. Like you can get it to work in the simulator, but so what? Like in the real world, the simulator is way different. And so it'll take a ton of work and a ton of effort to make that solution work in the real world. But with these world models, it doesn't matter what the domain space is. You get something that can work in the simulator, you can just rerun it then in the real world, and they'll just learn the structures of that new input data and do the same task of learning a world model. And then you can do supervised learning on it through like showing it examples of things that you want it to do and do the same thing. So anybody can actually do that. Anybody can then work with these freely, like easily available like simulators like Carla and any other environment to practice these skills.
Thank you very much for the advice. So would you have tips or advice, or maybe let's say recommendation for engineers who would like to enter the self-driving car space? Not necessarily on Mercedes-Benz, because I think you have seen a lot of engineers from a lot of companies. So if you can you can be specific or not, like you can choose.
Mm-hmm. Mm-hmm. I mean, I think one of the most helpful things is to follow like these kind of recent advancements with AI, because it can even like supercharge you as like a software engineer. Like the times I've used ChatGPT, and it's an awesome translator of code. And so, it's interesting because when you're coding, you can always like have like some syntax and then be like, but you'll maybe forget the syntax and then you have to like look it up. But then ChatGPT, it's like this awesome translator that you can just more focus on the high level, and then it can be more like a low level and just help supercharge your efficiency. So I think I would say that it's really useful to use these kind of tools, and it's amazing what they can do. Like even something like Carla, and you're creating a script to like launch traffic and do some specific task. I mean, in the past, you kind of have to Google it and you have to look through pages, and you'd hope that somebody kind of put together this tutorial, and then you take little bits and pieces of this tutorial and you put it in, and you kind of have to translate it yourself. And then that took a lot of time and a lot of effort to do. At the end of it, you have some script that works, and you'd be really excited and proud of yourself. But then with these kind of like ChatGPT, it's really good at understanding code, and it actually is really familiar with like Carla and these things you wouldn't imagine. And it can just describe it like, I want this script that launches this traffic agents and does this task. I want this sensor equipped to it. Okay, here's all the code that does that within a couple of seconds, and then you can run it and be like, oh, awesome. So it's really just like an efficiency boost. So I think like, learning to use those tools is really important for that kind of gaining that efficiency, saves time, um, and just being, creative and just curious and open mindset, and just be like exploring and just trying it out. I think this is so valuable. So
Spend the
you
time.
know, yeah, and it's just to have like some specific project in mind that you're really excited and passionate about in the first place. So that's the main anchor point. And then the tools could be anything. But if you have that one anchor point, then you can like start exploring the tools. Like I got this goal, and so if we're talking about self-driving cars, for instance, like maybe it's something specific. It can be perception and path planning. If it's like this world model, it's like the world model is just basically learning to generate and be the environment itself. So that could be your goal. And then it's just using the tools to try to make it do that. And then you can try the different tools and then see what the results are. And then when you get, you have some benchmark, some expectation of what the result should look like, you can kind of grade it off of that. And see which ones give you the best results. And just kind of work from there, I would say.
Okay, so basically you take a project as an excuse to learn what you want to learn.
Yeah.
So it can really be anything in the end, as long as what you want to learn fits in the project.
Yeah. And
I
then you could
actually,
make
the other
like
day I was
a,
working. I was looking at some code from someone who built an autonomous golf car, and that like he purchased a golf car and then he made it autonomous and added some software, and that was basically like his excuse to build his giant portfolio project, and then he joined
yeah.
Apple using that. That was really cool to see.
Yeah, that is awesome. Like, projects like that go a long way.
Mm.
Um, and it definitely gets recruiters' attention, right? Yeah. It's something to be really proud of in the showcase. Um, And yeah, whether it's like a physical robot or something virtual, it's just the project itself and building something that you feel is meaningful. And I think if you feel it's meaningful, there's a good chance other people will feel it's meaningful as well.
Yes, there is a story that you tell with that enhance it for sure. Thank
Definitely.
you so much, Aaron. It's been really cool. Do you have any, like, how can we find you, or if we want to learn more about you and what you're doing? And do you have any closing word?
Yeah, so you can check out the Discovery course on Udacity, which will be launching soon, Discovering World Models. And yeah, so check that out. And yeah, I mean, feel free to reach out on LinkedIn, or um, always happy to talk.
Sure.
Yeah.
Okay. Um, Thank you so much. It's been really nice to chat with you about world models and all of that.
Yeah. Thank you so much, Jeremy.